Hello friends, welcome to our channel. In this session, we are going to discuss about core principles on which each and every design pattern has been built. There are two core principles. Like first principle is program to an interface, not an implementation. And the second principle is favor object composition over the inheritance. These are the two principles upon which each and every design pattern has been built. Let's consider the first principle, program to an interface, not an implementation. Now let's understand this principle through an example. Let's consider this is a bank. You know that banks will offer different kinds of loans like house loan, vehicle loan, agriculture loan, and business loan, and many kinds of loans. But for the sake of simplicity, let's consider the bank is going to offer two kinds of loans. One is house loan and another one is the vehicle loan. So now the customer wants to know what is the EMI amount is going to get. He might opt for house loan or he might opt for vehicle loan. But at the end of the day, he wants to know what is the EMI amount he is getting every month. So to know that, he just opened an application related to this particular bank. So the particular application is designed in such a way that if he chooses an option like house, for example, if he chooses an option house, it will print the house loan EMI, and if he chooses an option vehicle, it will choose a vehicle loan EMI. It is very much simple application. Now let's have a look at this code. Here we have an interface EMI calculator which calculates the EMI. We have a method here, calculate EMI. This is an interface. Now let's consider we have two implementation classes here. One implementation class is house loan EMI calculator, which implements this EMI calculator, which implements the calculate EMI method, which has the implementation calculating house loan EMI. And similarly, we have an second implementation which implements the interface EMI calculator, which has its own implementation of calculate EMI, which is calculating vehicle loan EMI. Now let's come to the client application. In the client application, we have a main method and an user interface method, which is static. So let's consider this user interface will be accepting the user. Actually, suppose if a user wants to know the house loan EMI, he can simply choose an option house. If he wants to know the vehicle loan EMI, he can simply choose the option vehicle. By allowing user to choose any of these two options, it is just returning the objects. Either it can return house loan EMI calculator object or it can return the vehicle loan EMI calculator object. It will just create and return any of these two objects. So now let's let's run this code as well before looking at further. Okay. Now this application is asking to enter the loan type, house or the vehicle. So as an user, I will enter the option house. Okay. Now it's printing the calculating house loan EMI. Now it's calculating house loan EMI. Now it's again asking to enter the loan type, house or vehicle, because this particular application is in infinite loop. So that's why it is asking again. Now this time as a user, I will be entering the vehicle. Okay, now it's calculating vehicle loan EMI. So similarly, it keeps on continuing this application. Now let's have a look at the piece of code here, these two lines actually. So at the first line, we are calling the method user interface. In this user interface, it is asking for an option, enter either the house or the vehicle, and accordingly, the particular object is going to be returned, either vehicle loan EMI calculator or either the house loan EMI calculator or the vehicle loan EMI calculator. It is going to return any of these two objects actually. So This object has been received by the reference of type interface EMI calculator. This is the catch here. So here to catch the object reference, we kept the interface type here, EMI calculator interface type, because by doing so our code will be dynamic. This is the major purpose. So at the runtime it can collect any of the object type here. So depending upon the object type, it is going to calculate EMI at the runtime. So if it chooses an house loan, if the user chooses an house loan EMI calculator, then this calculate EMI is going to invoke. Suppose if he chooses an vehicle type, this particular calculate EMI is going to be invoked. Actually, it depends upon the user option. So that's why we have chosen an interface type here, EMI calculator. So this is called as programming an interface. Here, because we kept here interface type, because suppose let's say instead of the interface type, suppose let's say we have chosen the house loan EMI calculator type here. So then it is called as programming to an implementation. We don't want the programming to an implementation actually. Similarly, we can choose vehicle loan EMI calculator as well in place of this EMI calculator. This is also programming to an implementation. We don't want programming to an implementation, because if we do programming to an implementation, then dynamic programming is not possible, because at the runtime user can choose any of the option. Either he can choose house option or the vehicle option. Suppose if we hardcore here any of the particular implementation type, then it is going to be failed if the user chooses another type. So that's why we chosen an interface type here. This is called as programming an interface, not an implementation. This is one case. So that depending upon the runtime object, it is going to calculate EMI. It is a common interface. Calculate EMI is a common interface for both house option as well as the vehicle option. But depending upon runtime object, appropriate method is going to be invoked. So this is programming to an interface, not an implementation. So let's see the advantages here. By doing so, the code will be compact actually. So if the code is compact, then the number of lines of code is going to be reduced here. So if the code is not compact, then we have to incorporate lot of if-else blocks here actually, which is not compact at all. So by maintaining the compactability, another advantage is code readability actually. If the code is compact, then the code is more readable actually. It is going to improve actually. This is the one case of program to an implementation, not an interface. So let's have a second case here. Observe the return type here, EMI calculator. Again, we haven't kept loan EMI calculator here or vehicle loan EMI calculator as the return type here. We simply kept EMI calculator as the return type here, because this particular method user interface can return any of the object. Either it can return the house loan EMI calculator object type or vehicle loan EMI calculator object. It can return any of the object type here. So by keeping interface type as the return type, then it is again going to be dynamic actually, like for the same reasons which we have discussed just before. This is also another case of programming to an interface, not an implementation. So why this is the core principle for any of the design pattern? This is the question here. See, for any design pattern, it should be compact actually, and it should have lesser lines of code, and it should be more readable. Any design pattern, and any design pattern should support dynamic polymorphism, not static polymorphism. So by allowing the dynamic polymorphism, our application is always dynamic. It can be any type of design pattern. So that's why this particular concept, programming to an interface, not an implementation, is chosen as core principle for any of the design pattern, because maintain compactability, code readability, and further lesser lines of code. Yeah, this is all about our first principle, program an interface, not an implementation. In our next session, we are going to discuss about second principle, which is favor object composition over inheritance. Thank you.